So number 1 is using the Henderson-Hasselbalch equation to determine the pH of a solution in which the histidine group is 1% deprotonated. So that means that A minus would be 1%, and that HA is 99% for the R group or side group only. So A minus is 1%, therefore the concentration of HA is 99. So when you do the Henderson-Hasselbalch equation, it should be 1 over 99 when you do it. And because they're only talking about the side group, you want to use the pK of 6, which is for the R group of histidine only. You do not want to use the pK of the alpha amino group or the alpha carboxyl. They're too far away from the pKa of 6 or the pH that they want you to use. Well, actually, they don't give you a pH to use, but they said to do the R group. So the R group's pK is 6. Okay, and we know the ratio is 1 over 99, as I just mentioned. So when you do that problem, you want to do that. Then for question 2, it says compare the following peptides A through D to answer the following questions. More than one of the peptides may answer the question. The same peptide may fit more than one question. Okay, and this is from Dr. Bates at UCLA. I was a teaching assistant for her years ago. But for all of these peptides, please keep in mind it's assumed, and you want to do it at pH 0 initially. So you want to assume, even though it's not shown, like for A, you want to start out at pH 0 before you answer the questions and then change it. So have it written at pH 0. So we want to assume for like A is NH3 plus, then valine, then alanine, then phenylalanine, then isoleucine. And then initially at pH 0, you want to have COO hydrogen, where everything's protonated. Okay, initially until you see the question. So all of these you want to rewrite like I have here for A, and then read the questions. Also, you want to look up the pKs. If it's a quiz or exam, I give you the pKs. If you didn't buy the textbook, I did post the PDF of the textbook, which would have the pKs in it. Okay. So for any of these, if you're given the pKs, for instance, so to answer these questions, you may want to label them also with the pKs. If you look them up, like if the alpha amino group is 9, I would write it here for reference. Valine, I don't put anything. If you look it up, there is no pKa. For its R group, it doesn't lose anything. This is NH3+. This is just a dash saying valine is attached to amino group, but I could remove that. Okay, and then we have alanine, phenylalanine, isoleucine, and then the carboxyl group. I can remove that. That's the carboxyl at the end of it. And so I wouldn't put any more pKs till I get to, in this case, the carboxyl, which is 2. This amino acid is hydrophobic. But if you were to look at like D, look at C, it's a little different. We still do NH3+, okay, cysteine, asparagine, glutamic acid, tyrosine, and carboxylic acid. And then the alpha amino group again is 9. Just double check these, look them up. 8. Asparagine doesn't have one. Glutamic acid for its R group's a 2. I don't worry about the alpha carboxyl because it's in a peptide bond. And then tyrosine doesn't usually have one. And then actually glutamic acid here, should be at 4 for the R group. And the carboxyl is 2. Those are the pKa's. And you have to remember the rule that if the pH is lower than the pK, it keeps its charge. So anything below 9 for amino group would still be NH3+. Anything below 8 would still have cysteine at a sulfur and a hydrogen. Anything below 4, glutamic acid, is carbon, oxygen, oxygen, hydrogen. Anything below a 2, this carboxyl group will be as shown. Anything above 9, NH3+ would go to NH2 with no charge. Anything above 8, this cysteine would go to an S minus. Glutamic acid would go to COO minus if it was greater than 4. If it's greater than 2, this carboxyl group goes COO minus. So when you answer these questions, you want to have all 4 of them drawn initially at pH 0 as shown for these two, A and C, and then look at who's most charged at pH 7. So 7 for these two. 7 is lower than 9, so it's going to be a positive charge for both of these. Valine and alanine and phenylalanine isoleucine won't be affected. They don't have any pKs. This carboxyl will be a minus, a -1. So here it's just +1, and then you have a -1, so the charge would be 0 for that question 1. I'm just doing these two to show you. And then here it's +1. This has no charge at pH 7. This would be a -1 at pH 7, so they cancel out the amino group in this glutamic acid R group. Then you're left with a carboxyl, and so this should be overall -1. Okay, so those are some examples for question 1. So if you were just comparing peptide A and C, C would be more charged than peptide A. So that's an example there. Now I'm going to clear this drawing. Okay. And you do similar things, but you want to set up everything for A, B, D, and C, like I said. So the amino group should be NH3+ until you find out otherwise what the pH is. And alpha carboxyl at the end should be carbon, oxygen, oxygen, hydrogen, until you see what the pH is. Okay, so those are similar. Here's practicing naming it. Remember, usually anything that only the last amino acid keeps its full name. Calculate its isoelectric point. That's where, again, you're going to start at pH 0. So this would be NH3+, alanine, lysine, aspartic acid, COOH for the alpha carboxyl group, or the C terminus. And then you're going to put the pHs like I showed before up here, or the pKs up here, and take off one proton, half a proton at a time, and find the 2 pKa's of the ones that you wrote down here. They give you a charge half of the time. So it's going from +1 to 0, and 0 to -1, and averaging those two. If you want to draw the titration curve and have me look at it, you can have me do that. On the exam, you won't be drawing any, you would interpret one. Question 4 is having you do matching between primary, secondary, tertiary, and quaternary. Some of these choices may fit more than one level of structure, and some might not fit any. Okay. For question 5, you're supposed to determine which would be more likely to form an alpha helix or versus beta sheet. First of all, if you can rule out an alpha helix, then by default we are going to consider it a beta sheet. So if you see proline in any of these sequences, A, B, or C, it's not going to be an alpha helix. And then remember the other rule, you look at amino acid 1 versus amino acid 3 or 4. If they're like charges near each other, when you look at amino acid 1 and 4, because the way the alpha helix folds, it's not going to be an alpha helix, it'll be in a beta sheet. Negative charges cannot be within 3 to 4 amino acids of each other, or bulky items. So if you can rule out alpha helix, it's a beta sheet. Remember, antiparallel beta sheet, you have to have a glycine and proline next to each other. Okay, or a proline to glycine next to each other. But again, you first see if you can keep an alpha helix or not. If you can't, then it's a beta sheet. Antiparallel has a glycine next to a proline, or a proline next to a glycine. Okay, I mean, the answers are provided, but try not to look at the answers until you do them yourself to compare. Okay, I hope this helps. Thank you.